All right, welcome everybody. My name is Todd Harris and I lead product marketing at Percona. Now, I will be your host today. So thank you for being here. Thank you for taking time out of your days to be here and spend some time with us. For the next 45 minutes or so, we're going to be talking a bit about the importance of shard key selection in MongoDB, as you know, things like how to choose the best one, how it impacts performance, efficiency, and a whole slew of other things, as you'll hear from the team shortly. So I am joined by Vinny Grippa, a senior support engineer, Kimberly Wilkins, MongoDB tech lead, and Mike Grayson, senior MongoDB DBA. And before we get started, just a few quick items of note. You can't speak in this. All lines are on mute. Questions, of course, can be submitted anytime through the questions panel. Definitely use it. I can't guarantee we're going to answer things immediately, but if it does mix with the content that we're moving through, because we have a lot to move through, we will throw it in. But most likely it'll be towards the end. Worst case, we'll make sure to respond via email or have some sort of a blog post ready for you to answer some of those questions that you might have. So no worries at all there. Without further delay, it's enough of that. We'll get right into it. And Kimberly, I believe it's all yours.
All right, great. Thanks, everybody. So welcome. What we're going to be talking about today is the shard key selection. Try to help you guys kind of figure that out. And here are the specific agenda items we're going to talk about. First, we're going to do a quick sharding architectural overview. Then we're going to talk about the specific factors that you should consider. Then some hidden gotchas around things that kind of impact that. And then also, we've seen some pretty bad shard keys over the time, so we'll talk a little bit about those. Then great, you've got a busted shard key, but how do you fix it? What do you do about that? And then finally, we're going to talk about what's going on underneath the covers and then the future. Where are we going? What's going on now? Where are we going? So realistically, before we talk about sharding, we need to talk a little bit about the architecture. One of the reasons that MongoDB has been so successful in the past is because of its inherent replication ability. And so your basic underpinning there is your architecture is the replica set. The replica set consists of a primary and X number of secondaries. So in general, you're going to look at 2 secondaries for that. For production operations, it's recommended that you utilize 2 full data-bearing secondaries, not a primary, a secondary, and an arbiter. Because realistically, if you're in that setup and you lose one, you're down to just 2 nodes. But your replication occurs via the op log, and the heartbeat between all the nodes just sits there and says, hey, I'm up, in case you need to have an election, and create a new primary. Now, you can have up to 50 members in a replica set. So a lot of times people will add on 1 or 2 others for analytics or for backups. But the recommendation is, and you can also do it to reduce latency for different data centers. But you don't want to go too high because every replication is also a write. So going from this basic set, we're talking about sharding today. So what happens when you come into a shard? You add certain components and elements to the architecture, right? So the first thing you'll notice, obviously, you're coming in via driver. And the Mongo S tier acts as the router tier. So it's a query, it's a traffic stop, the query router. The other big component that's added are the config servers, which hold the metadata. So a lot of you guys are possibly, more familiar with relational databases. Think of that as like your data dictionary. So what MongoDB does, it takes a little bit further though, it makes that also a replica set so that you have redundancy at that layer, the same as you do throughout your shards. And then of course your shards, which are just individual replica sets. So that's technically your components of the architecture. But there's one more element that's not technically included, but is super important to the architecture, the sharding process, and that's the balancer, which goes around and is responsible for that. So now I'm going to turn it over to Mike, and we're going to talk about considerations for your shard key. Mike?
Thanks, Kim. So yeah, my name is Mike Grayson, and I'm going to be talking about selecting your shard key and some of the key considerations around what you should consider when you're doing that. So selecting your shard key. I can't emphasize enough that you want to think long and hard about what your data looks like and what it's going to look like. Not just what your data is now, but what it's going to look like tomorrow, a year from now, 5 years from now. Speaking for myself, I know we didn't always do that with relational databases. So with sharding, that's of the utmost importance. Working closely with your development teams and your architecture teams to kind of understand what they're planning for will really help you here. Knowing your access patterns. how your development teams are going to use it, how they're going to query it, insert to it, update it, delete it. All those are going to help you pick a shard key that's going to make those operations as painless as possible. And then the application itself, how is it going to flow? Is there going to be a middle tier between the application and Mongo? Are there going to be other ancillary products or software that's going to be reading from Mongo, as well as the application writing to it? All those put together will help you in selecting your shard key. There's also some other really important considerations. The cardinality of your shard key. You don't want to pick something simplistic like true or false, or you want to have a large frequency or very distinctive values for your shard key. You also need to understand how fast your data is going to grow on a daily basis, weekly, monthly, yearly. I've worked with applications in the past where the database was only really used quarterly, so we had to understand during that quarter end period how the database was going to be used and how we could shard based off of that. So really understanding your application is of utmost importance. And then how many people are going to use it? Again, with the example I gave, we had some definite peak times that we had to kind of plan for and architect for. There was also slow periods. Is it normal processing? Like it's always consistent? Is it batch oriented? Which is what my example was, where where at certain times it's busy and then it goes back to basically very low load. So some characteristics of good shard keys. So what does a good shard key look like? As usual in the database world, the answer is it depends. Again, on your application, your data set, and the use cases. But general rules of thumb, high cardinality, low frequency, very distinctive values, non-monotonically decreasing or increasing, basically not sequential. In the database, in the relational database world, a lot of the times when you partition, it's usually off of some kind of ID key. Through this talk, we'll kind of give you some pointers on why that can be pretty not good for a MongoDB shard key. And with that, I'm going to hand it back over to Kimberly, who's going to give you some hidden gotchas when you're selecting your shard key.
Great, thanks, Mike. So yeah, so some of the things that we look at, right, there are going to be some hiccups along the way, right? There are going to be some things that might not be inherently immediately visible. So one of the things is the shard key that you select is going to have an impact on your data distribution. And if you pick a shard key that is suboptimal, then you're going to most likely run into some pretty serious disk and size imbalances right off the bat. But one of the other things that people don't think of is you have all these collections, and some of them are sharded and some of them aren't. So for all of your, and you should obviously look to shard your larger collections. But for all of your unsharded collections, for each database that you have in a cluster, the cluster determines and identifies one shard as this shard is going to be the primary shard and going to hold all of the unsharded collections. So if you have 150 unsharded collections, they're all going to go on, for example, shard 3. But yet your sharded collections, you have 20 of them, those will be divided across your 3 shards, for example. So say you have an orders collection, and somehow it's grown to be 900 gig, and it's still unsharded. Well, then that means that your primary for this one is going to be for the orders for that database is going to be on shard 3. So you're going to have all of the data for your 900 gig collection and all the other ones on shard 3. So that means you're going to be getting hit with I/O, you're going to be hit with more memory if you have to do sort operations for all the queries, etc. And it's going to be targeted. So almost all traffic and activities and resources will be utilized there, right? So what will happen then, not only your I/O and your memory will be utilized, but your queries will start backing up behind that because everything is hotspotting, it's targeting that particular shard, not only that shard. And then you're backing up with that, your response times will start to suffer. So obviously you're going to need to do something about that and take a look at that. So some people always say, well, how in the world does one disk become more of a problem? these are the days when I can auto scale up and down and do whatever I want. I can increase the size on the fly. Yes, you can, but for the very reasons that I just stated, even if you add resources to that particular shard, everything is still going to be going to that shard. So that's why it's super, super important to make sure that you pick the correct shard key, all right? So the next thing that kind of comes up is, the order collection I just talked about, 900 gig, and it's one. Okay, all of a sudden you're having performance problems, and oh my gosh, I've got to shard this. Well, it's an expensive process. Right? First, you have to add the index to the large collection that exists because sharding is based on an index. So, and you're going to keep growing, right? So you keep going there forever, but you've got super busy applications. You can't take downtime. Your environments are going to feel the pain for the balancing of those collections because they already have the data in them. So the recommendations is to shard early and to shard often, right? Because the splitting of the chunks and the chunk migrations, the balancer process that I mentioned earlier will also negatively impact that performance. And I've seen this happen time and time again, right? Where people just aren't necessarily aware of that. They know they're growing, but they see it across the board, right? So then we're going through there. Okay. Talking about balancing, talking about chunks, talking about moving chunks. So the whole purpose of the balancer, the whole purpose of sharding is to evenly distribute your data across all of your shards, right? So that you don't have that problem of one or two shards getting hit more heavily than the other. So part of that process is the balancer moving chunk migrations, and the chunks are what the data is held. So you've got your default 64 meg chunk, your migrations are happening. But one of the things that happen is sometimes you have a problem, you have an election, right? So in MongoDB versions of 4.4.4, if there's any kind of a failover during so there's a multi-process phase of the chunk migration step. So the delete phase is when it removes from the old shard because it's moved the chunk over to the new shard. But if you had any kind of failover or election, 4.4.4, that could cause orphan data, and the orphan data would then cause further imbalance across yours. So it could lead to a crash. Now that is fixed and repaired after 4.4 and above, right? You've got more resilient chunk management in the failover, and then also a better orphan cleanup. But 4.4.4, there are many, many times that you would have to go in and do, one, identify the orphans, which could be a chore for itself, especially in version 3 and earlier. But then you would have to also clear. So you need, either way, no matter whether it's pre-4.4 or after 4.4, you need to be aware that this improved cleanup process will also cause more network bandwidth, right? The more balancing you've got on, you're going to be using more network bandwidth. So you need to watch out for performance impact of that. So lots of things to worry about, but the whole idea is that with scaling, with horizontal scaling, you get so much more overall, and you can grow, right? All right, so then that takes care of that. So going back to the balancer, so many times people don't realize the importance of the balancer and sharding. And then they think, well, okay, I see that I'm having some impact to my write performance because of all these chunk migrations. I'm just going to turn the balancer off. Well, if you turn the balancer off, you're asking for longer term problems. Yes, but you may say, my application performance is getting worse. Trust me, it will get worse later. You can add more resources, more CPU, more whatever, immediately, and it's going to mask the problem for now. But the longer that it persists without you fixing it, you're really just kind of kicking the problems down the road, right? And then eventually when you do have to turn the balancer back on, you're going to get hammered and your performance is going to be down. So the recommendations there are to leave your balancer on as much as possible, right? If you are ahead of the game from the beginning, then you can be able to leave that on or set it for a certain period of time. So the longer the balancer stays off, a lot of people turn it off when they're doing upgrades and then they forget to turn it back on. But the longer that it stays off, the more unbalanced your shards get, and the more resources you're going to have to use to prop it up. And if you had some problems for performance and you're not fixing the underlying reasons for those problems, then when you do finally turn it on, it's going to be worse. So this is, I've seen this just a lot of times, and it's just something that people don't think about because they're thinking, okay, I need the shard, I need to get this go, right? So here we go. The next one, one of the recommendations is if you're a very busy application, and more applications these days are 24/7 or almost 24/7. That's one of the reasons why MongoDB is used, because it can handle a lot of these loads, and it's built for the whole unstructured, semi-structured data. But to mitigate the impact of the balancing activities, you can use a balancer window. So one of the mistakes that people often make is like, okay, I'm going to set a balancer window, but I'm only going to make it from 1 a.m. to 3 a.m. And yet you've been hammering your system and adding your data all day long. The balancer window that you set should handle the balancing needs for all new data that you add for the day. So as your activity levels grow and your data size grows, then you might need to include a balancer window as needed. So if you have more bad data, you're going to have more balancing. And so this is when you use the balancer window, right? And there are the steps, the commands to do that. There are other things that you can do, like balancer settings. And Vinny's going to talk a little bit about a couple of the balancer settings that you can utilize here, just kind of off the cuff. Vinny?
Hi, everyone. My name is Vinicius, Vinny. Hi to everyone who is watching. I know that some friends of mine are watching this. As Kimberly mentioned, there are settings that you can do in the balancer that can, or you can speed up the process, or you can slow down. Always remembering that when you make things run faster, you are using more resource. It's natural, like you're using more CPU, in case of the balancer, more network, more disk, and not only on the source from where the chunk is coming, but to where the chunk is going. So you have two sides that can get saturated. And to slow down, it's the same. Like there are, I saw customers that prefer to have the balancer window running all the time, but going on a more slow pace. And I have customers that have the balance window well defined, so they speed up the process of the chunk migration. To do that, you can use two settings that are, I think it's the most famous one. It's when you when you go on the Mongo router, Mongo S, you do use config, and you do db.settings.update, and you can update two parameters. The first one, it's about the deleting the old chunks, which is wait for delete. And in this case, no chunk migration will happen until the chunk is deleted. And the other option, I think it's more common to everyone, it's the secondary turtle. And with that, you can specify, remember the write and read concerns that were introduced. It works in the same way. The secondary turtle, when you specify writes and with majority, you need to wait the majority of the replica set of that shard to acknowledge the write before moving on. If you want to make things faster, you can do only local or in the primary node. Basically, that's it. And I will be back soon to talk a bit more.
Okay, thanks. And then one thing, let me just go back a couple of slides here. I think I've got a little trigger happy on the finger. So one of the other things, right? Mike talked a little bit about, some of the things that you need to know about your application, that you need to think about while you're going into. So here you are, you're happy as a developer, and you're like, yes, I know exactly what my application is going to do. I know that this is going to be the perfect shard key, okay? For example, if you're going to do a social media type app of whatever kind, and let's do it on user ID, right? Because it's always going to be unique. It's always going to be extremely distinctive. Some of the two important things that Mike talked about previously. Well, the problem is you don't know how many users you have, and you don't know that some users may be more popular than others. And so you don't have a very large database and a very large, people to choose from, so to speak, whether it's a chat or whatever else. And so one person may be like super chatty, and one people may be getting liked more than others, right? So what happens with that is something called hotspotting, similar to what I described with the disk earlier. And the other problem that can happen with that is you'll create jumbo chunks, because all the data, there will not be enough distinctiveness for that particular shard key of user ID, and then there's too much frequency, right, on there. It's that particular one's going to get. So what happens is all your data will get stuck into one or two of the chunks, the data parts, and you will get the jumbo chunks, and then that will further negatively impact your disk balance and then your performance over all tanks. So now that I went back and picked that back up, now we'll go back over and we're going to talk about, Mike's going to talk about some examples of the bad shard keys that we've seen. And we'll probably all kind of pop in with some things about that. All right, Mike, you want to go ahead?
Yep, thanks, Kimberly. And yeah, I'm sure we all have some pretty good war stories here. So I'll give you some examples and some impacts of bad shard keys as seen in the wild. Again, this is similar to the user ID where you think, okay, I have lots of clients or customers. Let me shard by client customer ID. This works great until you get that one whale client. Example being that large supplier that we probably all use. Can you imagine how big their data set would be versus your mom and pop shop down the street? That's kind of where you get to those disk imbalance issues and jumbo chunks and things like that. Similarly, I've seen people try to shard by a location, but you're always going to have your major metropolitan areas, your your New Yorks, your Londons, Mumbai, etc., versus your small municipalities. So that's another bad shard key I've seen. And then again, to reiterate, the monotonically increasing fields sequences in relational database parlance. And then sharding on fields with a high frequency. The example given, at least in the United States and England, a last name like Smith is going to be probably one of the most common names there. So you're going to have way more of those than other last names or family names. Similarly with Robert or Michael, you're going to have more of those than you're going to have others. So it might not be a good shard key. We've seen that one kind of tank performance as well. Vinny or Kimberly, is there any others you want to chime in with?
One of the things you mentioned, again, monotonically increasing, like the sequence type things, just to kind of go a little more about that. What happens with that is you have a sequence. And so all of your data is going to be put into one shard. Then that shard builds, and all your data will be put in one shard, and then it goes to the next shard. So it defeats the overall purpose of sharding. The whole purpose is you want to spread it out across it. So that's why you want to avoid those sequence type, the monotonically increasing or decreasing ID fields. So those are some of the things. But I think Mike's got a couple more examples here coming up.
Yep, exactly. Thanks. So a popular example is kind of social media. Imagine you were creating an application that kind of curates from all the different social media sites. You might think some kind of social media ID would be good, but then you're going to have social media sites like Facebook and Twitter that are going to be way more and Instagram that are going to be way more popular than the others. You might have ones that are regionally popular as well. So you're going to have a high frequency, but you're going to have a low distinctiveness. Kind of continuing along that, you're only going to have 7 or 8 distinct values. Granted, there's certainly more than 8 social media sites out there, but still you're going to have a low cardinality and kind of a fixed number. Again, some way more popular than others. And that's going to lead to hot shards. That's going to lead to disk imbalance, and et cetera.
And Mike, one other thing real quick. If people, this is like kind of actually a great example. If we, on slide 21 here, if you take that and you turn it from being horizontal to being vertical, think of that as your shard. Think of it, if you had chosen to shard on what type of social media. So if you had sharded on social media type, you'd have Facebook with 75.6% of the data, so to speak, and then 43% for Instagram. So that's kind of a good way to think about it in a visual sense. And then, Mike was going to talk about the bad shard key performance.
Yeah. So again, with the monotonically increasing or decreasing IDs, you're going to always be right. And Kimberly mentioned this already, but you're going to always be writing to a hot shard, where basically your max, wherever your max value is, that shard is always going to get in your writes. So you won't be distributing your writes. You won't be getting that part of the shard performance gain, because you're only going to be writing to one shard. Similarly, if you're always reading your most recent writes, they're all going to be on that one shard basically until they kind of get balanced out. So you're going to be reading from that one shard primarily all the time. So, and then jumbo chunks, again, that's going to be if you have, again, using the customer ID as an example, when you have the Amazon versus the mom and pop store, Amazon's going to be more likely to create a jumbo chunk, because MongoDB is going to try and put all their data into one chunk. It's going to go over the chunk size, and it's going to be unable to break it up easily. So, which can lead then to disk imbalance problems, because if it's a jumbo chunk, it can't get migrated, which is going to then lead to your I/O problems. And you kind of see the cascading failures here, where because of your disk imbalance, you're going to start having I/O issues, which could lead to slow queries. Because again, you could be primarily reading from one shard, or if on the converse side, you could be doing a lot of scatter gathers if you're using a hash shard key, which has its own pros and cons, which can lead then to slow performance, crashes and downtime. So you kind of see that it keeps snowballing. It might seem like a small issue at first, but it kind of snowballs all the way down to potential data loss or corruption with orphan documents and things of that nature. So you can kind of see how it can go from bad to worse really quick, just from a bad shard key. So with that, I'm going to hand it over to Vinny, who's going to give you some pointers on what you can do if you're already in the situation where you have a busted shard key. How can you mitigate the impact? How do you get out of it? How do you kind of start to fix it?
Thanks, Mike. Hello again. On this section, what I will try to show you guys is what exactly, what happens when the shard keys are bad. What we can observe from the server, what MongoDB tells us from its metrics of what is happening. So first, my colleagues already mentioned this. When you have bad shard keys, the operations, inserts, deletes, updates, reads, they are non-targeted. And by this, what I mean is that a single query will hit all the shards all the time if not using the shard key. For example, if you have 10 shards, remember, we are talking about 10 servers connected in the network, 10 primaries will have to acknowledge and we'll have to reply back to the MongoOS. Another thing that usually customers comes and say look, but my SH status, I can see that we have the same number of chunks, 10 for each shard, and it's equally distributed. And okay, that is fine. It means the balancer is working. But what happens is, as Mike mentioned, if you have a big whale, a big customer, all the data, suppose you have 1 gig for each and 90% of your operations is on Amazon, then one shard will get saturated. So data size distribution can be balanced, but not the data. That's what we need to keep in mind. The other effect that is really clear, it's the constant spikes in resource consumption. I'm going to show you guys a few dashboards about what I mean in practical terms, but this is a very big issue. especially because nowadays most of the things are cloud. And even when we are talking about, okay, this is not related to me, I'm using Atlas. No, you are wrong, because on Atlas, if you don't have enough resource, probably if you don't fix the things, probably you will receive an advice to upgrade the instance. So it means more money that you could be saving doing things better. And as a consequence of that, what I mean is resources wasted with operations that does not belong to that shard. And why that? Because you have CPU, memory, and disk being requested on shards that does not have the data that you want. Here is an example from PMM where you can see what is the effect when the queries start running high and they are not targeted, they are not optimized. The first thing, as we know, MongoDB works with tickets. We have 128 for reads and 128 for writes by default. This can be changed, but it's not the topic of this webinar. And when we can see here at around 8:39 minutes and a few seconds, the number of write tickets went down to 0. That is because the shard was receiving a lot of operations that were not using the shard keys, and a lot of data had to be fetched from the disk and written as well. As a consequence, we can see the number of connections start to increase, and it is going from, let's say, 4K and going around 9K. And each connection, I did some tests, and each connection uses around 4 megabytes of data. So if you are putting, because of the send and receive buffer, if you put this 4 megabytes multiplied by, you have extra 5K connections, then your server can get easily saturated, and MongoDB can even be killed by the OON. In practical terms, what the application will see, it will observe, it will wait, and we will see keyword operations. This means that we have operations, write or reads, in this case are writes, that are waiting to be processed by MongoDB. As a consequence, as we can see here, disk utilization, it's really clear that you have several minutes where disk is being pushed to its limits. And again, when we are talking about cloud, okay, I'm going to increase the IOPS, I'm going to double it. Okay, it might hide the problem, not solve, but you will spend more money for it. And the disk write wait time in this case, for databases, all databases is generally a good maximum is 5 milliseconds. And we can see here a single IOPS is waiting more than 2 minutes to go and the storage retrieve the ACK. So it's a huge time. More problems, and this time is from Linux perspective. If you look at the message, you can see, because operations start to query, the application does not have a connection pool properly configured. The application says, okay, I need this data, and start opening a lot of connections requesting the same things. And then you start flooding the MongoDB port on the server. So then you have to start thinking about, how can I tune the network stack? We have some recommendations for that, but again, the main concern is about the bad shard keys and how to make our operations run smarter, not make bad things run faster. That's what I mean. And how do we mitigate the impact? There are two situations, of course. One of them is when you are creating the collection on a sharded environment. So it means the data is not there, you're going to populate. And with that, you can use the pre-splitting feature. So what means is that you are going to create the chunks in all the shards. And when you start inserting data, this data is going to the proper shard. So the balancer will not have to move this data after. A quick example in practical terms, how you can shard. So I'm using enable sharding for a school database. And I'm sharding the collection. The namespace is school.students. My collection is student. And we can imagine that student ID is like the social security number. It's a random number. It does not increase monotonically. It has a high frequency and high cardinality. Sorry, a low frequency and high cardinality. And here we can see the output, the collection is sharded. MongoDB returned OK for me. Now that the collection is sharded, how we can split? Since I know that I'm going to use student ID, I'm going to split, let's say, I'm going to load 100,000 students at the first initially. So I'm going to split into chunks of 10K. And when I execute this little for loop here, which is pretty simple, it's sh split, and we are splitting the chunks. So we will have chunks splitted equally among the shards. Of course, this shard for, it can happen that you have an odd number of shards and one of the odd number of chunks, and one of the shards will have one chunk more than the others. This is not a problem at all. Only if we had like a huge difference that we should start worrying about. If your database is already sharded, what we can do, before MongoDB 4.2, our options are very limited. What I usually recommend is exporting out data from MongoDB, drop this bad sharded collection, and create a new empty collection with the proper shard key, pre-split, and restore the data back. So that's what I usually recommend, because for me, it's the safest way. I think Kimberly has some experience about hacking the config server. So Kimberly, if you want to mention.
Yeah, so, like Vinicius said, 4.4.2, this was, a process. This was quite a big process, right? And for customers that are running continuously or they have large collection, trying to change the shard key after the fact was not easy to do. And that's one of the reasons why MongoDB has made some of the changes to being able to find shard keys, et cetera. But you would have to, depending on the size of your collection, possibly take a downtime, or you would have to at least make a copy of the data to another collection with a different name. And then you would have to do a dual write type situation from your application in on that. Just going back to this real quick, you'd have to do a dual write, right? And then the new shard key in your new collection with the pre-splits, and then add the data back in. But the thing that you would have to do then, you would also have to hack the config servers to change the metadata. So if you mess up your config database, then you are losing the map to all of your data, because all the data that exists in chunks, they're not data in and of themselves. They are the data, but only through the map that is the config server. So anytime you're messing with the config server, you get into big trouble there, right? And so, I think you're right there, Vinicius, next with the next slide.
Thanks.
Yeah,
thanks, Kimberly. And as Kimberly mentioned, there is the option for you to hack the config server. But now things are improving, so the future is a bit brighter for us. On MongoDB 4.4, you can refine the shard key. if it already exists. But I must say, this is not a silver bullet, because you can't modify the prefix of the shard key. You can only add new fields. So it's not a entire modification. It's not a new shard key. We are just appending new fields to it. And this is an example of the command on MongoDB 4.4 about how to refine the collection shard key. And then I'm specifying, let's say my previous shard key is customer ID. Now I'm adding order ID as well. And what's happening under MongoDB's hood? I saw one question here, and this section is going to explain exactly that, which is, how does the process of keeping the MongoOS in sync work? And this section will talk exactly about this. As we can see, we have here the client app, as my colleagues already showed something similar, the MongoOS, or also known as Mongo Router, the shards, and the config servers. And nowadays it's a replica set. And how do we keep in sync? There is a thing called a routing table that the MongoOS and the MongoDBs have it, which is the metadata information is in memory for these servers to make things faster. And to make the concurrency control, the routing table has versions. So what happens, for example, when, let's say, this shard 0 had to move chunk around, so my routing table is on version 7. My MongoOS does not know that, so my MongoOS is trying to insert a document, but I'm on version 6. What happens? It looks like, okay, I'm on one version below of the shard, so I'm outdated. I need new metadata to proceed. So I will go to the config servers, request this information to update my routing table. And with that, remember, like, the network is much more slow than the CPU and L1 cache, L2 memory, and etc. So you have latency involved. So one query that could be running 5 milliseconds, because the metadata is outdated, it may run in 20 milliseconds, because you need to update the metadata and there is latency in the network. So it's 4 times more slow. Of course, 20 milliseconds is not that much, but it's for you guys to have an idea of like how things can get worse fast. Like from 5 milliseconds to 20, it's 4 times more. So once I update, okay, I have the correct version, and now I know which shard I need to insert this data. So okay, I will tell shard 1, please write this data for me. It is where it belongs. The reference that I used here, it's from Alibaba, so that's why you see this branding from them. This blog is very complete. I enjoy reading Alibaba as well, and also GitHub. A lot of things that I learn is from analyzing the source code and the documentation in it. Kimberly, next, she will talk about the feature of the shard keys and what will happen, what MongoDB is planning for the next versions.
Great, thanks for this. All right, so before we talk about the future, we'll look a little bit to the past. So we had a couple of questions submitted, and I want to go ahead and answer those because they were related to the earlier part of the for the presentation. So one of the things is, what about reverse sequences? So I kind of answered that already, but it doesn't matter whether it's monotonically increasing or decreasing. Either way, all the data will still be targeted and going into one particular shard versus the other. So another question is about the pros and cons of hash shard keys. One of the ways that you get around this, that whole sequence aspect, is by using a hash, right? So a hash shard key, either of a field that you have, or preferably of the entire object underscore object ID. So one of the best use cases for a hash shard key is when you have a lot of write activity, right? So say your application is like 70% writes and 30% reads. So very, very heavy writes, and especially with smaller updates and smaller writes, then you would use a hash of your underscore ID. And the beauty of that is that it will spread the data, the chunks, out evenly across all of your shards. Now, kind of the downside, one of the cons of using a hashed shard key is that if you have a lot of queries, if you have more queries than you do writes, or if you have a lot of queries that use intensive sorts and need a lot of data from different places, then your queries will have to go out to all the different shard members as opposed to, and gather that information and then bring it back into the memory and sort it. And so Vinicius had mentioned, OOMs, out of memory errors. You run into that a lot of times with your Mongo S if you don't have your connection pool setting, but you also run into that because of these sorts. So if you have complex queries, then and a lot more read activity than write activity, then that would be a downside of when you would use a hash shard key. The more positive is when you have a very write-heavy activity and you need to spread that data out across all your different applications. So that handles two of those type questions there. The other question is, what about using a 5-byte random value in the object ID as a shard key? Say the last 3 bits to divide the shard key. So the problem is the object ID, the underscore ID, object ID field, by default has a built-in time component in it. So if you just use especially the last parts of it, right, as a non-sharded shard key, then you would really be hurting yourself because it is by default a sequence and serial and then concludes that time component. So that's why one of the best practices is to use the entire underscore object ID hashed as a shard key from very heavy write activities, right? So then the next question I think there was that the recommended size for sharding, recommended size of database compressed disk, consider on sharding. So whether it's compressed on disk or not, WireTiger handles the majority of your compression activities, right? And so it's kind of built in there, so you don't necessarily need to worry about that. What you think about, it's not necessarily the size of your database, but it's the size of your collections. So, and depending on if your activity. So if you have a lot of small writes, then it's better to have fewer shards. If you have a lot of complex queries and a lot of aggregations, then I would suggest utilizing fewer number of shards, say 5 to 10 for 5 terabyte. You have a general rule of thumb is no more than like 500 gig per shard as a maximum, because then you run into manageability issues, right? But anytime a single collection is above like 20, 30, 40 gig, you should consider sharding that, because if it's growing fast and it's going to continue growing fast, you want to get ahead of that before it happens. All right, so now before we kind of go through any of the other questions, because I just wanted to kind of pop in there for a second, I'm going to talk about the future of shard keys, and then we'll open it up for the remainder of the questions, all right? Okay, so the future of shard keys. So Vinicius mentioned, in 4.4 we had the refinable shard keys where you could add more distinguishing data and characteristics to that, right? So and that was great. That was the first step, but not the silver bullet like Vinicius mentioned. It helps, but you have to remember that under the cover, activities are occurring that are incurring additional writes. So which is something we're expecting in MongoDB 5.0. Of course, we won't know until they release the full real version, the production version, because right now it's just a release candidate development version, the 5.0 that's out there. But we're expecting the ability to have fully changeable shard keys, so full resharding. And that's going to happen via a new reshard collection command. The syntax for that is not available out there wildly yet in there, but basically under the covers, it's going to be creating a clone with the shard key and then a whole lot of moving pieces. So it's similar to all the stuff that I mentioned before about hacking, creating a new collection and then pre-splitting the chunks based on the new shard key, then moving the data over and then moving all the chunks over. So those are some of the things that we're talking about there. All right. So next, some other things that we're looking at, just kind of seeing, again, hard to find until it's fully released, but we're seeing some new parameters that are out there and around batch sizes, limiting batch operations, which is a great thing because some of the biggest things is you have a great functioning application, you're running along, you're happy, and it's very, very busy, it's very active, right? And then all of a sudden you need to dump a month's worth of data in there. And so they're adding some additional things. And these are going to be supposedly things that you can reconfigure on the fly so they can be done and tuned at both startup and also at runtime, right? Again, so there may or may not be time series collections, and we've heard rumors of time series collections coming out. So will they shard time series collections? Time series collections are inherently buckets anyway, right? Where, okay, all this data for this particular time goes here, and then we fill this bucket, and then we fill this bucket. So then if you're going to shard those buckets, if you think of it from like an underscore ID hash type of thing, then you're going to be taking the buckets and then you're going to be redistributing them out. But there's a lot of MongoDB tickets out there, so we won't know until it comes out. But there's a lot of information that we're looking forward to and some of these changes to start to play around with and make available for the Percona. And so that take it kind of back to everything, no matter what, you do need to come back and you need to put the time in ahead of time, as Mike mentioned. You need to pick the best shard key possible, and hopefully you're going to do that the first time. And so I think Todd's now going to hand it back over to you, and then we'll probably address the questions. And thank you guys all.
Yeah, let's cover some questions, and we've got a little bit of time. We've got like 9 minutes left, and gone through a lot of slides. It didn't feel like that long, so that was kind of cool. So we've got a bunch of other questions, and thanks, Kimberly, for addressing those that came in while the team was presenting. So I'm just going to float a few of these out here, and whether it's Kimberly, Mike, Vinny, you guys decide, or you can all answer them if you like. So I'll start with one of the three that we have pending. So one of the questions is how to force balance or to balance data of a collection with 5,000 records if it's not balancing data on its own. So forcing balancing.
Okay, I'm going to answer this one. So we have one question for each. Actually, when we talk about balancing data, it is not about the number of documents. It's about the chunk size. So MongoDB is not going to start balancing this collection unless it crosses the default value of the chunk size with 64 megabytes. Okay. If you have these 5K documents and it's less than 64, it's not going to start sharding. If you want to see, just for practicing, please don't do this in production. You can reduce the chunk size to, 1 megabyte. And then you will see the chunks start moving. But again, this is not recommended. It's only for studying purposes. Todd.
All right, perfect. So let's try another one here. Hash key. So hash key always better as sequence. I'm sorry. Is hash key always better for a sequence column? Can you please explain how does data balance for a composite shard key?
Yep. So this is Mike. I'll take this one. So hash, as with all databases, there's no one answer. So I would to answer the first question. Is a hash shard key always better for a sequence column? No. Oftentimes, yeah. A lot of the times, and we mentioned this through the talk, adding a secondary field to kind of break it up more, because you might think, again, even if you've got it so you don't have the hot shard issue, there might be other considerations there. So adding another field, excuse me, adding another field into your shard key can also work. And let's see, last part of the question, can you please explain how this data balance for a composite shard key? So with a composite shard key, it basically puts those two values as the shard key. To use a simplified example, let's say one field is X and the other field is Y. together, those two values would be the shard key. And then MongoDB is going to kind of split them by that. So you could have, in theory, if your values are x equals 1 across the board, it's really going to end up sorting you by y. Or if they're both unique, it's going to use them both to partition them up across the shards. And then it basically does assuming you're using ranged based sharding, then it's gonna be doing the ranges by the entire shard key, both values. So I hope that answered the question.
Mike, thank you.
All right. Then we have one of the questions is, if we have some field with absolutely random values and high cardinality, when we can't make any logical ranges for chunks, is the best way to use a hash shard key? Or is it the only way? And this is mostly inserts and reads and no updates. So this is one of those, this depends. But if you have a field with absolutely random values and very high cardinality, then realistically, you should be able to use that field for your, you need to think about too, you're mostly inserts and reads, but mostly inserts and reads, does that mean 50-50 inserts to reads, or does that mean 70-30? So you think about those type of things. But I'm going to assume that you are primarily 50-50. So absolute random values, high cardinality for a field, you should be able to use that field to shard on without doing any hash, right? If you're heavier right, and if it's increasing at all in any manner, then you would want to shard. Now, the other thing is knowing your data now versus knowing what your data may be. If you're just starting out with your application and you have a random data set and this is what your data is going to be, but what about 5 years down the road? What about 2 years down the road? Are these patterns going to change? So you have to think about all those different things. And in this particular case, if you're heavier read write, if you have smaller chunks, smaller documents, then I would still consider hashing. But if you have that absolute randomness that you're sure of and the high cardinality, then would consider going ahead and making that particular field your shard key. All right.
Beautiful. Kimberly, thank you. We still have a couple minutes. There's another question. We have someone who is using Percona for MySQL, which is awesome. Question was, what does Percona provide for MongoDB? I'll give a quick answer to this, but the pros on the call here can absolutely expand on that. But I will say, if you're interested in MongoDB or our version of MongoDB, it's a hardened version of the community edition of MongoDB. It has a lot of great things that you might only find in Mongo's Enterprise Edition, such as some data security enhancements, things like encryption, some authentication plugins, some audit logging. We've also have Percona Backup from MongoDB, which is a great backup solution specific for Mongo. We also have a non-product features, which are our support and consulting and managed services teams, which really round everything out in terms of your experience with MongoDB. So I will say that for us, this is a big month for MongoDB, as it is for MongoDB themselves, with Mongo Live coming up. And part of the reason why we're doing this webinar, and we're doing a whole bunch of others around MongoDB, is to really communicate the fact that as MongoDB users, you have more options than just using Mongo's version of MongoDB, obviously. These options, the ones that we offer, they avoid lock-in, they're less expensive support contracts, more flexible to your scaling needs, and of course, frees you from the proprietary licenses that you might be subjected to. So this is the whole point of this, is to give you some more exposure on obviously some of the hot topics around MongoDB, with sharding specifically here. But we also have other topics coming up. For example, next week, we have a webinar that's coming up on converting from MongoDB Community Edition to Percona Server for MongoDB. So I'd really recommend checking that out if you want to keep this going. We've obviously got a lot of blog posts on it, but if you want to find out more about that, you can do this inside of BrightTalk where you are right now. Just search for Percona in the toolbar. You may even see it at the bottom where it recommends other sessions. Just do a search for Percona and you'll see the registration link for converting from MongoDB Community Edition to Percona Server for MongoDB. That said, I will let the team, if I missed anything or you want to have any last words from Kimberly, from Mike, from Vinny. Otherwise, we're gonna wrap it up to respect everyone's hour here.
Yeah, this is Mike.
Yes, good.
just thank to everyone that joined us. I hope I could, we as a team could help with some clarification to make the decision of shard keys a little bit better for you. It was a pleasure. Thanks, Todd and Kimberly and Mike.
Yeah, great. Thanks, you guys all. And thanks to everyone out in the audience. Feel free to reach out to us or to Percona if you have any additional questions. And obviously, as we mentioned, we do have the Percona server for MongoDB as well. So thank y'all.
Yeah,
awesome.
Thanks everyone very much. And just to add to kind of what Todd said, the two other MongoDB related products that Percona offers is a Kubernetes operator, because we all know Kubernetes is super popular. And then our monitoring tool, PMM, Percona Monitoring and Management, also supports monitoring MongoDB. So thanks everybody for listening.
Beautiful. Thank you guys very much. Thanks everyone. And we'll see you next week for our next webinar.
Great. Thanks.